Let's get started just so
Okay.
we don't fall behind. And so for everyone in the class, obviously you guys know who I am. I'm Oscar, one of the founders. And we have a new instructor that's joined us. Mark and Joel are still with us, but they're teaching some of the other classes. But Raghav is one of our new instructors who is a college student. He goes to Cornell and he's studying electrical and computer engineering. So for those of you who are interested in going into a possible engineering path at some point, this is your guy. Obviously, he's a great instructor, but you can also ask him questions about what his experience has been like as a student. Even if you are in middle school or high school, it's never too early to start asking. So Raghav, I'm gonna let you take it away. I'll be here if anybody needs anything, but go from there.
All right. Thanks, Oscar. Hi, sure. Hi guys. Hi, Andrew, Charlotte, and Edgar. I don't know if there are more people here right now, but well, that's great. And as Oscar said, my name is Raghav Kumar. You guys can call me Bobby. That's my nickname. And yeah, we'll be making the robotics kit 2, which is the controller. And I've been told that you guys have already made the kit 1, which is a great thing that you guys have done. I just wanted, before we start, let you guys know, please stop me whenever you want to ask any questions. I want to make this class as interactive as possible. And if possible, turn on your videos. But I totally understand if you can't, if you cannot. So that's also fine. So yeah, let's get started. Oh, sorry. 1 second. Yep. So just a quick agenda. We'll do some introductions for like 10 minutes, maybe an icebreaker. Then we will go into a project overview, like where we are in terms of what you guys have already built and what we're gonna build. And then I want to like talk about how joysticks work. With the project that we have, we might not really like delve deep into the understanding of individual components. So I think it's really important that you guys know how these joysticks, tiny pieces of hardware work. And then in the last 15 minutes, we will go on to, build a part of the controller. So yeah, well, that's me. My name is Raghav. This is a small picture. I think I love surfing. That's one of my hobbies. And yeah, I study ECE, which is Electrical and Computer Engineering at Cornell University. In my current class, we are building a robot which goes something like this. This is supposed to follow light. So you can probably see that it follows light. I'll flash the flashlight on the left side or the right side, and it turns. And I don't know, you might be surprised, not surprised, but this is the microcontroller. This is an Arduino, and this is like a small Arduino. It's called a Nano, and it's called an Every, actually, a Nano Every. And this is from the Arduino family that you guys are already using and will be using. So very powerful microprocessor, very powerful tool. So another fact about me is that I work at Tesla, or I interned at Tesla. I was working at their failure analysis team, which is a team that makes sure that all the failures in the car are perfectly addressed and handled. I made this tool. Here you can see a tool. It's called a lock-in tomography tool. And I just wanted to ask you guys, does anyone know what a short circuit is in this class or among the people who are here? Have you maybe heard of the word short circuit ever? Seems like no. So, hi Andrew. So yeah, seems like you guys haven't heard of what a short circuit is. So a short circuit is basically when like two wires that are supposed to go through a resistor or pass through a certain resistive component, they touch each other directly, and a high current flows through that circuit, and it tends to overheat components and burn things. So that often leads to a lot of failures in a electric car. And this tool, what it does is that if you give it a like a board, like a electric board, it can, using a camera, tell you where the short circuit is. So it saves a lot of time and effort in trying to find the short circuit. And here also, actually, I used Arduino. This is called a Teensy Arduino, and it's like a baby Arduino. So yeah, so like Arduino is again a very ubiquitous in engineering. And yeah, just like a small, I like love to have fun. I love to do stupid stuff. This is me like trying to do a headstand on a paddle boat in a swimming pool and falling shortly after. So yeah, I think it's important to work, and it's important to work hard and play hard. Yeah.
Right up to and I'll just to stop a second for the students in the class. Is everyone familiar with Tesla? Just in case, like, where have you guys heard of Tesla before? You can put it in the chat room too if you don't feel like talking out loud. Well, I'll let you guys think about that, but if you can figure out where you might have heard of Tesla, I'll let you guys run with that. Ah, there you go. Cool. Electronic cars. Awesome.
Yes. Yeah. Cool. They're building electric vehicles in comparison, like in contrast to the fossil, like the petrol or gasoline gas cars that you might be familiar with. And the mission is to transition to a more sustainable world, a world where like renewable resources power our generate electricity, and with that electricity we drive cars, we fly planes, we power our houses, all of that good stuff. So yeah, so that is Tesla. Okay, so now that I have introduced myself, I would love if you guys could take 5 minutes and put in the chat your dream invention, or one invention that you think that the world needs today, or something that you just want to build in the future. I'm sure that all of you guys are interested in building things, inventing things. So take 5 minutes and put something in the chat, and I will also think for 2 minutes as to what I want to build. Something I want to build, yeah. Oh, Oscar, I was literally thinking about a teleportation device. I was just gonna put that in. Well, I'll have to think about something else then. So mine would be to build a device with which we can, I guess we have that already. Like we have that, like you can breathe underwater with it. Or like, I guess another one would be cheap.
Unless you're thinking like artificial gills.
Yeah, something like that. But I think cheap jetpacks would be cool. So Edgar says the machine that allows you to eat without using an ounce of energy, besides digesting the food. Oh, so you mean like that you can eat it and it won't give you calories? Is that what you mean?
That would be amazing, actually. Oh, you won't have to
chew. You won't have to chew. Oh, I see. So I see. So you can just okay, like got it. So it just exists, and you just get all the nutrients that you have. Like you don't have to sit to have food, basically. That's pretty clever. That would be pretty sweet, actually. Yeah, it would save us a lot of time eating food. Yeah. All right, I think as other people are thinking about this, we can move forward. Please keep putting it in the chat, and we will keep discussing about it as we go. All right. So, well, I guess that was a quick introduction. I'm still waiting for your inventions and your dream inventions. But moving on to the project overview. So, I have another one. Let's see. Time traveling, yeah, Charlotte. That's the omnipresent dream, right? Like everyone wants to time travel, and meeting your future selves and meeting your past selves. I think that would be really cool. I think, yeah. I don't know if the physics allows us, but maybe in the future we find something that allows us that. Yep. Yeah, there are like such good books written on time travel, some good science fiction. Anyway, so let's try to figure out what we're trying to do here. So I'm assuming you guys have already built or are in the process of building this robot, like this Wi-Fi control robot, which is a pretty complex thing in and of itself. But this course, we will be building the controller that is supposed to control this robot. So just like, why do you guys think like we need controllers? Anyone like wants to jump in and contribute, or like just want to put in the chat, like, why do you think we need controllers in the first place? Why can't we just have the robot? Like, why do drones have robots? So we can make the object do what exactly? So like, exactly, Edgar, perfect. So basically, controllers are the way that we control the robot or the object that we've made. It is the link between that car, that drone, that aeroplane, or whatever, and us, like the operator. So it goes two ways, right? So like the controller is supposed to transmit information that we send to the robot, and the controller is also sometimes able to get information from the robot to us, like in terms of feedback. So for example, like today you have drones, and the controllers have this really nice screen that shows you what the camera on the drone is seeing. Like it gives you feedback. It gives the operator feedback as to what the drone is seeing. And using these joysticks or using these buttons, you can send information to the drone. So it's a duplay kind of information transfer. You can send information and you can get information. I'm sure you guys know what a PlayStation or Xbox is. Does anyone have a PlayStation or an Xbox here? Just say yes or no on the chat. Oh no, okay. Yeah, even I don't. I actually have a very old like PS1, like PlayStation 1 or something. I never really got into, even Andrew doesn't have it, but Oscar has it. Nice Oscar. But yeah, I never got into video games. But for the people who have it, they might know that feedback can also come in the form of vibrations, right? So there are actually small vibrating motors inside of these controllers here that vibrate when they're programmed to. But our controller won't be that fancy. Our controller will have buttons around here, and I really find it very. I'm really curious as to how these joysticks work, and I hope you guys are too, because today we will do a small deep dive into how these joysticks work. And just to show you, this is what our controller should be able to do by the end. So you will be able to move the robot around. So our controller will be pretty cool too, I think. It'll be pretty nice. Yeah. So yes, okay. So yeah, okay. We did a good project overview, some introductions are done. Now let's just talk about how joysticks actually work. So at its very core, a joystick is supposed to send information from the controller, from the operator to the robot, right? Like I talked about how there are duplay information streams, like how you can send information and how you can get information. Joysticks are usually just sending information to the robot. And so also the joystick is sending, in our case, the joystick would be sending information to the Arduino. So whenever you move the joystick, the Arduino would get to know. So Arduino is the main brain of our controller, as it was the main brain of your main, like the car robot. And how does a joystick even like send information? Like, how do you even start understanding how it sends information? So to begin with, a joystick works in like a 2D. Imagine the space to be a 2D grid, right? Like, do people understand what a 2D grid is? Like what a grid is, X and Y grid. So you have the X axis and you have the Y axis. Do people understand that? Or do you want me to go over it maybe? Okay, sweet. Thanks, Edgar. Thanks, Charlotte. Okay, so people understand what a grid is. Okay, so whenever you move the joystick using two channels, like an X channel and a Y channel, like X pin and a Y pin, the joystick sends information about the regarding the X and the Y position of the joystick. So, for example, if this is the Y axis and this is the X axis, if you push the joystick completely to the right, it will send a X0 and a Y512, which is the maximum. And if you push it the other way, sorry, it's not the maximum, my bad. It's the half of the maximum. And if you push it up all the way, it would give X512 and Y1023, which is the maximum of Y. So you can see, like on the diagonals, you have a certain value. On the horizontal and the vertical, you have a certain value. So that is basically how from a very high level how a joystick sends information. And of course, there's also the push button. You probably, like, I don't know if you can probably hear it. So that's the push button. Like that can also be used to send information. So the key to understanding, like the key to actually build projects in a high level also is that whenever you have a hardware module, the first thing you should know is, like, or try to understand is, like, how does the pinout work of the of that module. So as you can see, let's just go over all the pinouts here. So we have the ground pin. Like I'm sure you guys know what the ground and the 5-volt pin is. So this is the power. So you connect the power line on your from your, like, there will be a 5-volt power line in the Arduino. You connect that to this 5-volt and you connect the ground to this ground pin. And then X and Y carry the information regarding the X and the Y axis. So I told you, like, how there were two channels that send information regarding the X and Y plane. So the VRX sends the information about the X channel, and VRY sends the information about the Y channel. And someone tell me what SW does? Any idea what SW does? Okay. So SW actually sends information regarding the press of the button. So it would be a 1 or a 0 if it is a 0, if you press it or not. And you can see here, right, like on the right diagram, you can see ground and 5-volt going to ground and 5-volt, but then VRX and VRY go into A0 and A1. So this is interesting, right? Like, and this button press goes to pin 8. Can someone tell me, like, why VRX and VRY go into the analog pins and SW goes into the digital pin? Like, do people understand the difference between analog and digital pins? Why do you think that's happening? Feel free to speak up. Doesn't matter if you're wrong at all. Oops. Oh. Sorry, 1 second. Yeah, doesn't matter if you're wrong at all. Like, just shoot your shot. Anyone, any idea? Okay, I guess people are just a little nervous. Okay, so basically, X and Y pins go into the analog pins because these are analog values. So what are analog values? Analog values mean that these are like continuous values, right? So if you move the joystick, you can go from 0 to 2 to 3 to 4 to 5, all the way up to 1024. Whereas the button pin is either just two values. It's either a 0 or a 1. So the way the Arduino reads is, is if the digital pin is a high, that means a 5 volt, and if the digital pin is a low, that means a 0 volt. But with a analog pin, you can, between 0 and 5 volts, you can go in multiple small, very tiny steps. So for example, like you can record a little bit of a tilt, a little more of a tilt, a little more of a tilt, and finally the most tilt. But with the press, you can just do a press or no press. So a no press or a press, no press, press. So it's just, that is the reason. So whenever you have something that registers analog values, I don't know if you guys have used photosensors. I think you have used it in your project, like the robotics kit 1. Even photosensor just sees analog values. It sees a 0 to 1024 in very tiny steps, because light is analog, right? So it's continuous, not discrete. Maybe this is a little more clear as we go on in this project. So I'm assuming people understand this, but do people want to take a shot at explaining this code as to what is happening here? Do people understand what's happening here? This is not very difficult code, I think. But does anyone want to take a shot at explaining this? Or I can go through it. Anyone who's feeling a little confident, who thinks that they know what's going on? No one? Okay, no worries. Okay, so in the first 3 lines of the code, we are defining, right? Like we are saying, okay, we will make a variable called SW pin and assign it 8, X pin to 0, and a Y pin to 1. So these are obviously mapped to certain pins. So for example, if you go to your Arduino, it says digital here. On digital, you can see there is 8, which is a digital pin, and 1 and 0 are the analog pins. So that is why 0 and 1 are analog pins and 8 is a digital pin. And then in setup, here you tell what mode these pins are. So why is SW pin, which is the switch pin, why is that an input? Can anyone tell me why that is input? Anyone understands why? Again, guys, no worries if your answer is wrong. No judgments, nothing. This is, we all here to learn. No worries. Okay. So the reason this is an input is because when for the Arduino is getting information from the joystick, right? So like the joystick is doing something and that information is coming into the Arduino. So, and the computer will then read that. So the small chip inside the Arduino, the computer chip, is reading values that are coming in from the joystick. So the joystick is changing the values from 0 to a 1 or 1 to a 0, and that information is being read by the Arduino. So that's why it's an input. And this switch pin is an example of something we call active low. So I don't know if you guys are aware of what this means, but an active low means that on the event, so when I press this button, the value of the pin the value of pin 8 or the switch pin would go low. So you might have seen earlier that, if you do an event, if you press a button or if you flick a switch, the value goes from a 0 to a high. So then okay, switch was pressed. But with the toggle pin, or at least in this example, it's an active low, meaning that if you press it, the value will actually go low. So initially, you just set it high because initially the default state is not pressed, right? Like right now, the button is not pressed. The default is high. So when I press it, it'll go low. So for example, on the output here, on the serial output, you can see switch is 1 1 1 1 1, and then here you actually press the switch, and then the value goes 0. So this is known as an active low pin or active low line, which means that when the event occurs, when the button press occurs, it goes low instead of going high. And here you can just see, right? Like it's just doing a digital read of the switch pin and analog read of the X pin and the Y pin. Maybe this is more detailed than you guys want, but does anyone have an idea why the analog values only go from 0 to 1024? Like, why is it that it doesn't go over 1024, or why doesn't it go into negative? Any idea? All right, tell me one thing. Do you guys know what bits are? Any idea what bits are? Bits, bytes. You might have heard bytes, right? Like gigabytes, megabytes. Any idea what bits is? No idea? Okay. So basically, the way the computer... so Andrew, thanks Andrew. So you guys don't know what bits are. Okay. Maybe a lot of this is going over your head. So let me know. Like I am not very sure as to if I'm going too fast, or just let me know if you guys don't understand. I can repeat or slow down. Okay. So what bits, basically like a computer sees values in like zeros and ones, right? You must have heard it like, the computer just reads zeros and ones. So whenever you move your joystick, the Arduino reads a bunch of zeros and ones. Like it only sees a bunch of zeros and ones. And for the joystick movement, there are 10 bits, meaning 10 states of 0 or 1. So there will be a 0, 1. Then if I could write and show you, that would be great. All right, maybe next time I'll explain to you what bits is. But essentially, there are only 10 bits that represent the state of the joystick, and that means that you can only read up to 1024 like states. So if I had 20 bits, so then with 20 bits, I could read even more, like even a higher value of states, and like even higher value of joystick movements, more resolution. My Arduino would know even more precisely what my joystick is doing. As you decrease the number of bits, the Arduinos cannot sense like very, very small movements. It just can see like very, very large movements. And that is not good, right? Because you want even a tiny shift to be registered by the Arduino. Anyway, I can maybe explain this later sometime in like another curiosity session. Cool. So I think maybe you guys are getting some idea about how a joystick works, maybe not. But let's talk about like how do they like, okay, I explained to you on a high level, right? Like if you move it, it'll send information to the Arduino. But what happens when you like move it, right? Like when I move this, what will happen? Like what's changing? So if you guys had a joystick around you and if you can pick it up, that'll be great, because I want to just show you like there's this very small like thingy here, like it's like a white object, and there's another one here. So if you see that if I move my joystick, if I move my joystick either way, this thing shifts. And similarly here, if I move it front and forward or this way, it shifts. So basically, when you move the joystick, some mechanism is happening inside the joystick, right? By any chance, do you guys know what a potentiometer is? Is that something you guys have heard of? Andrew, maybe you can, or Edgar or Charlotte, anyone, do you guys know what a potentiometer is? The dial in the first kit. Oh yeah, I mean Oscar. Yeah. Maybe you guys remember. You guys might know it. You might just not remember it, right? So a potentiometer is something that you can. Correct. Great, Andrew. Thank you so much. So a potentiometer is something, right, which with when you twist it or you move it, it changes the resistance, right? So imagine something like this, right? Like on the right, this is like, imagine if current is coming from this wire here, this is the resistive track. So this is carrying some resistance. If current is coming from here and it is going back from here, if this thing is if this golden object is very close to where the current is coming in, if this is very close to where the current is coming in, the path to ground would be very short. So the resistive track would not come into the picture a lot. And if this wiper, this is called a wiper here, if this wiper is all the way to the right, then the current has to travel all the way to the resistive track, and then it will go back to ground. So when I move this around, this wiper is moving around, and because the wiper is moving around, it is changing the resistance inside the small silver box. And when that box, the resistance of this box changes, the Arduino can sense that, okay, there is like a change in the value of the resistance, or rather the small like circuitry inside here that can sense that there is a change in the resistance, and appropriately it sends information, right? So if I move this around, if I move this like this, it will change the resistance of the X and the Y pins, and it will send. So remember there were two pins, the X pin and the Y pin. Similarly, there's the X potentiometer and the Y potentiometer. So when you move this around, these potentiometers change their resistance, which changes the voltage across them, and the pins can register that, and then they send that information to the Arduino. Yeah, that may be a lot of stuff, guys. So please, I'm here. You can ask me questions. I would love to explain it to you guys. And so just like a quick demonstration, like how it works. So you can this doesn't really explain the whole thing, but just imagine like these are like, this is like a shaft, right? So this is what this is. And if you move this around, there is like some movement happening here, and because this is moving, this is changing like the resistance like of the current that is flowing in. Like you can't see the current flowing in right now, you can't really understand much, but this is just to show that moving the joystick on the top moves these mechanical structures inside. And what will happen when you say push it? Right now you can only see it going X and Y. Right now it's going like this and this. But what if it goes diagonal? What if you move it diagonal? When you move it diagonal, both of these like move. So again, if you see these small structures here, when you move them, when you go diagonal, both of them would move a little bit. So the resistance changes a little bit on both the potentiometers, which I think is pretty cool. I think I really enjoy working with joysticks. Really cool device. Alrighty then. So I think that is the end of our, sorry guys, I just keep going forward. So that is the end of our Let's Be Curious part. And I am now excited to build part of what we have here. So I am hoping that you guys, and you, Charlotte and Edgar, I hope you guys have your kits around you so that we can start building a little bit. I am gonna keep switching from this screen share to like a live demonstration. I think that would be a nice way to. Okay, so just first of all, I mean, you guys know, right? So this is the base shield. This is what will help you connect a lot of different parts of the controller to each other. And this is the main Arduino, the main brain of the system. Then you have this bottom plate, right? So the bottom plate has a the right and a left, and then it has these grooves here. So you should be able to tell, like it looks a little different here, but this is what it looks like. And I want you guys to also take out some NP nuts and screws. I can show it to you once I stop screen share. And then I can just go over all of this on like a live. Okay. So can you guys see me like bigger now, I guess? So Oscar, just wanted to confirm that you can see me, right? Like,
Yeah, we can still see you. You're still the same size. We're in like the view is the gallery style.
Can they change it to like a speaker thing? Like you can just click on the.
I think so.
I mean, maybe
Yeah.
on their screen, maybe it is like speaker. Or
Yeah,
maybe
you can like on the top right corner, they can click on either gallery or speaker. So
exactly. So on the guys on top right, there is a tab that says view. Just click on view and then go click speaker. So that will show you my hopefully like the whole screen is my face. So that will be better. Okay, so I'm gonna take out some screws and start building this in front of you. And if you guys can also do it, that'll be great. I'd love to see your faces and like love to see what you guys are building, or if you guys have any problems, I can like help you debug that. There's a word, debug means to help you solve it. I'm just taking out all the screws right now in order to start putting this stuff. Can anyone just confirm if they can see me like in speaker view instead of gallery? Or do you still need help with that? Just say, yeah, we can see you in gallery view or not. Okay, thank you, Charlotte. Just one tip, guys. Thank you, sir. Yeah, got it. Thanks, Andrew. One tip, guys. So basically, the way the Arduino goes is like this, right? So there is one hole here, and then one hole up top here. So maybe Oscar is able to answer this better. Hey, Oscar.
Yes.
So are there supposed to be two Arduinos, or are supposed to be using the one from?
It should be one, but I'll double check to make sure that you're not supposed to have a second one. But
so do they dismantle the one from before?
Yeah, I think it should. Let me double check, but I think you should have a second Arduino. If you're missing that, Edgar, we can send you a new one, or another one, so you don't have to take your robot apart. Yeah, okay. So you should have a second one actually. Now that I'm thinking about it, because that way you'll be able to control the robot when you're done. So if you're missing that, just let me know, and we can put one in the mail for you tomorrow or tonight.
So Edgar, do you have a second? So I'm assuming you don't have a second one, right? Bummer. What about you, Charlotte and Andrew? Do you guys have extra Arduinos?
I don't either.
Oh, you don't either? Oh, okay. Bummer.
Out for you. The cool thing is, like, we're recording this, so just in case, if we need to.
So what we can do is I can just go over making it, what we're gonna complete today, and hopefully by next class you guys have your Arduinos, right? Yeah, okay. I think that's a good plan. So I will just show you what I'm doing. So this is the plate, right? So there should be a left and a right and a left here. And you place the Arduino such that these holes, they line up with this hole and these two holes on top, on the bottom. So they should line up something like this. And I would say that you first you have it like this. You take a screw and you put it on top on like that. So this is what I did. So I just put one screw like that. And then what I'll do is I'll flip it over, right? I'll flip it over. I will take my bolt, hold my screw from here, and start screwing it a little bit. Right knot. Oh yeah, sorry, that was not the right knot. This is it. There you go. So not hard at all. So like one nut is done. Then I take another nut, another screw, put it in, flip it. So flipping makes it easier, right? Because then you can see. You can also keep it. Oh, hey, Reed. Hi. So we're just building the controller. We have, so this is the plate. If you can open your kit, you will see there's this plate. You can take the Arduino and then screw things. And then if you turn it around, you can just put the nuts like that. Yeah, this is not very hard because you can just use your hands to screw it. And so here's the thing, right? Like I can also share it to you, or maybe you can see it. So, but I also want to show you this. But look at this. So I think the last one, right? This top hole. This is a little. Sorry, guys. So this is a little tricky because there isn't too much space for this nut. So like it becomes very diagonal and it's a little hard to put it in. So the way I fix the situation is I use a smaller nut actually. So a smaller, I'll just show it to you. A smaller nut and a smaller screw. Well, let me just take them out and I'll show it to you what I mean. I'm not sure what the size, what is the name of these, but I use these like really thin, so you can see the difference, right? Like I don't know if you can see it on screen, but I'll just stop sharing. I don't know if you can see this difference, but they are little. So this is the one that I'm using, what I'm using now. It's like a little tinier and little easy to put in, and also the difference in the nut sizes is also, man, this is going to be hard to show, but yeah, this will be a little hard to show, but you'll be able to see this difference in the nut size also. So I'm gonna put this here, goes in perfectly. I'm gonna screw this, turn it over like I did turn it over for all of the rest. So you guys can see, right? Like yeah. So if you guys can see, like it is much, or maybe you can't see, like I guess you can see, right? It's like much smaller than this bigger one. And if you turn it around, these nuts are also much bigger than this one. So then you don't have that problem, right? Like if you see from the side, the problem, like it's not like straining the Arduino, it's not straining these pin headers. So I think that's a better way to handle the situation. And once you're done with that, if you're so inclined, we will go over this again in next class. But you can take this shield, right? You can take this shield and you can just line the pins, all the pins. I hope you can see this. Just line all the pins and enter this like this and push a little bit so that this firmly is set. And hence you have basically almost completed your, or not completed, but you've done a bunch of the work that is required for the bottom assembly, the bottom plate. We will obviously go over this later, but once you start working on the top assembly, the top part, this is how the joystick would fit in. And our hope is to, like, you know, join these together like this and be able to play or control the robot. And this is very similar actually to a PS5 or like a PlayStation or a Xbox, right? You control that also like this. Very cool. It should also have some buttons here. If you're so inclined and you want to work more, you can add lights and stuff to your robot using the buttons. It would be super cool. This can be clicked. So a bunch of things that we can do. I am super excited to see where this goes and super excited to be working on this. And I'm super excited to be teaching you guys. So yeah, I guess that's all for today. Any questions, guys? We have a few minutes. We have around 8-10 minutes. Just let me know. Will, if you have any questions, please let me know. Yeah.
Yeah, we'll make sure we send out those Arduinos as well.
Yes. Yeah. You should. Yeah. You guys will probably have it by next class, so then we can continue from there. I mean, this didn't take much time, so we can like just go over this really quickly even in next class if you guys are. Andrew, Charlotte, Edgar, Will, do you guys have anything that you would want to learn specifically about? Like, is there anything that you're interested in, something you learned in science class? Oh, more people are entering now. Oh, those are
those are for the next class.
I see, got
it. Yeah, there's a first robot class.
Oh, I see, got it.
That's okay.
Yeah, no, sweet, that's fine. I'm sure that class is probably bigger, right?
A little bit, yeah.
Mm-hmm. But super cool, guys. Like Andrew and Charlotte and Edgar, you guys have already done the creator set and the robotics 1 kit. That's pretty cool, I think. Like, yeah, solid work.
Yeah, so for usually like the last 10 minutes of class, if anybody has questions, they can ask. I mean, it could be about anything. It doesn't have to be about the kit, but it could be about.
Yeah, just about anything. Like you can call them graduating college this in a month, so you can ask about college. You can ask about how engineering is. It's pretty hard actually, but it's really nice, dude. Like I mean, guys, I really love what I study, and you really understand like how the world works, right? Like you really understand how circuits work, how mobile phones work, how Wi-Fi works, how cars work, like how electricity grids work, what is AI, what is machine learning, what is autonomous vehicles, like all that stuff, all that cool stuff that you hear in the news maybe, or your science class. You can learn about rockets, you can learn about rocket engines, a lot of cool stuff, yeah.